Hello, and here we are at the FinetLink channel. If you have followed all the videos that are uploaded in this channel, now we are at the last material of Introduction to Network for CCNA. And with other videos that are uploaded, now you are at this final module where you have, for the moment, most of the functional knowledge needed to set up your own network. And now you are ready to build a network, and not only to build, but even to verify if that it is working and even troubleshoot some common network problems. And the topics and the objective of this material is implement a network design for a small network to include a router, a switch, and an end device. And the topics that we will see will be to identify the device used in a small network, to identify the protocols and application used in a small network. We even explain how a small network serves as the basic of large network. And we will use the output of the ping and traceroute commands to verify connectivity and establish relative network performance. We even will use host and IOS commands to acquire information about the device in a network. We will even describe common network troubleshooting methodologies, and we will troubleshoot issues with device in the network. And as for the small network topologies, first of all, you have to know that the majority of business are small. Therefore, it's not surprising that the majority of business networks are also small. A small network design is usually very simple. The number and type of devices included are significantly reduced compared to that of a large network. Let's focus on the small business network that is shown here in the slide. This small network requires, as you can see, a router, a switch, and a wireless access point to connect wired and wireless users, an IP phone, a printer, and a server. Small networks typically have a single WAN connection provided by DSL, cable, or Ethernet connection. Large networks require an IT department to maintain, secure, and troubleshoot network devices and to protect organizational data. Managing a small network requires many of the same skills as those required for managing a larger one. Small networks are managed by a local IT technician or by a contractor professional. Large networks, small networks require planning and design to meet user requirements. Planning ensures that all requirements, cost factors, and deployment options are given due consideration. One of the first design considerations is the type of intermediate device to use to support the network. There will be listed more information about the factors that must be considered when selecting network devices. So one of the factors is the cost. Cost of a switch or a router is determined by its capacity and features. This includes the number and types of ports available and the backplane speed. Other factors that influence the cost are network management capabilities, embedded security technologies, and optional advanced switching technologies. This expanse of cable runs required to connect every device on the network must also be considered. Another key implement affecting cost consideration is the amount of redundancy to incorporate into the network. Another factor is speed and types of ports and interfaces. Choosing the number and type of ports on a router or a switch is a critical decision. Newer computers have built-in 1 gigabit per second network interface cards. Some servers may even have 10 gigabit per second ports. Although it is more expensive, choosing layer 2 devices that can accommodate increased speed allows the network to evolve without replacing central devices. Another factor is even expandability. Networking devices are available in fixed and modular physical configuration. Fixed configuration devices have a specific number and type of ports or interfaces and cannot be expanded. Modular devices have expansion slots to add new modules as requirements evolve. Switches are available with additional ports for high-speed uplinks. Routers can be used to connect different types of network. Care must be taken to select the appropriate models and interfaces for the specific media. And lastly, it is very important to take into consideration even the operating system features and services. Network devices must have operating systems that can support the organization requirements such as Layer 3 switching, network address translation, dynamic host configuration protocols, security, quality of service, and even voice over IP. When you implement a network, can create an IP addressing scheme and use it. All hosts and devices within a network must have a unique address. Devices that will factor into the IP addressing scheme include the end-user devices, where is the number and type of the connection. It can be wired, wireless, or remote access. Server and peripheral devices, where it can be printers and security cameras. And even the intermediary device, including switches and access points. It is recommended that you plan, document, and maintain an IP addressing scheme based on device type. The use of a planned IP addressing scheme makes it easier to identify a type of devices and to troubleshoot problems, as for instance when troubleshooting network traffic using a protocol analyzer. Here in the slide, we will refer to the topology of a small to medium-sized organization. And this organization will require 3 user LANs, as you can see, and has decided to implement a consistent IP addressing scheme for each of those LANs following this plan. And in this last figure, it is displaying an example of 192.168.2.0/24 network devices with assigned IP addressing using the predefined IP addressing scheme. You may notice that assignable IP address range were deliberately allocated on subnetwork boundaries to simplify summarizing the group type. Another important part of network design is reliability. Even small businesses often rely heavily on their network for business operation. A failure of the network can be very costly. In order to maintain a high degree of reliability, redundancy is required in the network design. Redundancy helps to eliminate single points of failure. There are many ways to accomplish redundancy in a network. Redundancy can be accomplished by installing duplicate equipment, but it can be also be accomplished by supplying duplicate network links for critical areas. This is shown even in this figure at this slide. Small networks typically provide a single exit point toward the internet via one or more default gateways. If the router fails, the entire network loses connectivity to the internet. And for this reason, it may be advisable for a small business to pay for a second service provider as a backup. The goal for a good network design, even for a small network, is to enhance the productivity of the employees and minimize network downtime. The network administrator should consider the various types of traffic and their treatment in the network design. The routers and switches in a small network should be configured to support real-time traffic such as voice and video in appropriate manner relative to the other data traffic. In fact, a good network design will implement quality of service to classify traffic carefully according to priority during time of congestion. As you can see in this figure, priority queuing has 4 queues. The high priority queue is always emptied first. If your network is for a small business, you want that business to grow and your network to grow along with it. This is called scaling a network, and there are some best practices for doing this. Growth is a natural process for many small businesses, and their networks must grow accordingly. Ideally, the network administrator has enough lead time to make intelligent decisions about growing the network in alignment with the growth of the company. To scale the network, several elements are required as the network documentation, where you can document physical and logical topology. You have to do the device inventory, where you will list the devices that use or compromise the network. You have to check even the budget to document it, where itemized IT budget including fiscal year's equipment purchasing budget, and with the traffic analysis by using the protocol and application and service and their respective traffic requirements. Even those should be documented, and these elements are used to inform the decision making that accompanies the scaling for a small network. As the network grows, it becomes important to determine how to manage network traffic. It is important to understand the type of traffic that is crossing the network as well as the current traffic flow. There are several network management tools that can be used for this purpose. However, a simple protocol analyzer such as Wireshark can also be used. For instance, if you run Wireshark on several key hosts, can reveal the type of network traffic flowing through the network. The flowing figure here displays Wireshark protocols hierarchy statistic for Windows host on a small network. And in this screen, there are capture reveals the host in using IPv6 and IPv4 protocols. The IPv4 specific output also reveals that the host has used the DNS, SSL, HTTP, or ICMP, and other protocols. To determine traffic flow pattern, it is important to first capture traffic during peak utilization time to get a good representation of the different traffic types, and even to perform the capture on different network segments and devices, as some traffic will be locally to a particular segment. Information gathered by the protocol analyzer is evaluated based on the source and destination of the traffic, as well as the type of traffic being sent. This analysis can be used to make decisions on how to manage the traffic more efficiently. This can be done by reducing unnecessary traffic flows or changing flow pattern altogether by moving a server. And in addition to understand changing traffic trends, a network administrator must be aware of how network use is changing. Many operation systems provide built-in tools to display such information. For example, a Windows host provides tools as the Task Manager, Event Viewer, and Data Usage tool. These tools can be used to capture a snapshot of information such as operating system and operating system version, CPU utilization, RAM utilization, drive utilization, network application, and even the network application. Documenting snapshot for employees in a small network over a period of time is very useful to identify involving protocols requirements and associated traffic flows. A shift in resource utilization may require the network administrator to adjust network resource allocation accordingly. The Windows 10 data usage tool is specially used to determine which applications are using network server on a host. And the example is shown here in the slide. Whether your network is small and new or you are scaling an existing network, you will always want to be able to verify that your components are properly connected to each other and to the internet. And now we will ensure that your network is connected. By using the ping command is the most effective way to quickly test layer 3 connectivity between a source and device IP destination IP address. The command also displays various round-trip time statistics. The ping command uses the Internet Control Message Protocol, echo request, and echo replay messages. The ping command is available in most operating systems, including Windows, Linux, Mac operating system, and even in Cisco iOS. On a Windows 10 host, the ping command sends for consecutive Internet Control Message Protocol echo request message and expects 4 consecutive Internet Control Message Protocol echo replies from the destination. Let's see an example. Let's assume the PCA pings PCB as it is shown here in the figure. The PCA Windows host sends for consecutive the ICMP echo request message, sometimes referred as an ICMP echo to the PCB. The destination host receives and processes the ICMP echoes, Internet Message Control Message Protocol echoes. And as it is shown here in this figure, the PCB will respond by sending 4 Internet Control Message Protocol echo reply message to the PCA. Here it is shown the command output where the PCA has received echo replies from the PCB verifying the layer 3 network connection. The output validates layer 3 connectivity between PCA and PCB. A Cisco iOS ping command output verifies from a Windows host. For instance, the iOS ping sends 5 Internet Control Message Protocol echo message as it is shown here in this output. And you can see that there is an output character with as it is listed here. The iOS ping command displays an indicator for each Internet Control Message Protocol echo reply received. Here in this table there is a list of the most common output characters from the ping command and is the explanation for each of those characters. A standard ping uses the IP address of the interface closer to the destination network as the source of the ping. The source IP address of the ping here in the figure is ping 10.1.1.10 command on router 1 will be that of the this interface G0/0/0 as it is illustrated. The Cisco iOS offers an extended mode of the ping command. This mode enables the user to create special types of pings by adjusting parameters related to the command operation. Extended ping is entered in privileged access mode by typing ping without an destination IP address. You will then be given several prompts to customize the extended ping. By pressing the enter, you will accept the indicated default values. For example, let's assume that you want to test connectivity from router 1 of this network 192.68.10.0/24 to the LAN as 10.1.1.0/24. This could be verified from the PCA. However, an extended ping could be configured on the router 1 to specify a different source address. As it is illustrated here in this example, the source IP address of the extended ping command on router 1 could be configured to use this G0/0/1 interface IP address. And here it is listed the output when you configure an extended ping on router 1 and specify the source IP address to be of this interface. The ping command is useful to quickly determine if there is a layer 3 connectivity problem. However, it does not identify where the problem is located along the path. Traceroute command can help locate layer 3 problems area in a network. A trace returns a list of hops as packet is routed through a network. It could be used to identify the point along the path where the problem can be found. The syntax of the trace command varies between operating systems as illustrated here. There is a trace command in Windows and Cisco iOS. That is in the Windows host, and this is on Windows 10. The only successful response was from the gateway in the router 1. Trace requests the next hop timed out as indicated by the asterisk, meaning that the next hop router did not respond. The timeout request indicates that there is a failure in the internetwork beyond the LAN network, or that these routers have been configured to not respond to echo requests used in the trace command. But in this example, it shows that there is a problem between router 1 and router 2. A Cisco iOS Traceroute command output varies from the Windows Traceroute command. For instance, let's refer to this topology and mean that now we are using the Traceroute in the router 1. Here would be listed a sample output to Traceroute command in this router. The tracer validated it could successfully reach the PCB. Times out indicate a potential problem. For instance, if the host 10.1.1.10 was not available, the traceroute command would display this following in the router 1. Like the extended ping command, there is also an extended traceroute command. It allows the administrator to adjust parameters related to the command operation. This is helpful in locating the problem when troubleshooting routing loops, determining the exact next hop router, or determining where packets are getting dropped or denied by a router or firewall. The Windows Traceroute command allows the input of several parameters through options in the command line. However, it is not quite like the extended Traceroute iOS command. Here it is a display the available options of the Windows Traceroute command. And the Cisco iOS extended Traceroute option enables the user to create a special type of trace by adjusting parameters related to the command operation. Extended Traceroute is entered in privileged access mode by typing just Traceroute without its destination IP address. iOS will guide you through the command options by presenting a number of prompts related to the setting of all different parameters. By pressing Enter, accept the indicated default value. For example, let's assume that we have to test connectivity between PCB from router 1 LAN. Although this could be verified from PCA, an extended Traceroute could be configured on router 1 to specify a different source address. And as it is illustrated in the example, the source IP address of the extended Traceroute command on router 1 could be configured to use the router 1 LAN interface IP address, and here it will be shown the output. One of the most effective tools for monitoring and troubleshooting network performance is to establish a network baseline. Creating an effective network performance baseline is accomplished over a period of time, measuring performance at varying time and loads, which assists in creating a better picture of overall network performance. The output derived from network commands contributes data to the network baseline. One method for starting a baseline is to copy and paste the result from an executed ping, trace, or other relevant commands into a text file. These text files can be time-stamped with the date and saved into an archive for later retrieval and comparison. Among items to consider are error messages and response time from host to host. If there is a considerable increase in response time, there may be a latency issue to the data address. For example, here in this slide, we will have the output for the ping command captured and pasted into the text file. Here it is for this date, and you can see that the ping round trip times are less than 1 millisecond, and a month later it is repeated the same command and it is captured, and as you can see here, the ping round trip times are much longer, indicating a potential problem. Corporate networks should have existing baseline more extensive than we can describe in this course, but professional-grade software tools are available for sorting and maintaining baseline information. For the moment, we are covering a few basic techniques and discuss the purpose of the baseline. And that was all about the first part of Build a Small Network. See you to the next session, and do not forget to subscribe at this channel. Hit the notification button for the new videos that will be uploaded, and if you like this video, share it with your friends. See you soon.